Little about me or about my passions. I like to educating and teaching young people at local universities and high schools in our country, in Slovakia. And I would like to share oftentimes some practical knowledge with students. But yeah, it includes also practical hands-on labs and exercises, technical exercises. But the real question is, how can I deliver these practical exercises, which works in my home lab, to students on their local universities or on their own machines? So in the past, I've used, next slide please. Yeah, in the past I used virtual machines, of course. But there were always some kind of issues like insufficient resources in local universities. Like, yeah, we do not have so much RAM, we do not have so much hard drive space and so on. Or there were always at least one people in the class who, I have a new MacBook and this virtual machine for Intel and AMD's processor didn't work on my machine and so on. So then I switched to the virtual PCs in the cloud. It works good, but then it turns out that many local universities and high schools have very strict policies for the outgoing traffic. And the things like SSH or RDP are blocked, and the students cannot connect to my virtual PCs in the cloud. Then the next iteration will be like a virtual PC in browser. Thanks to the solutions like NoVNC and so on, it is very easy to set up and to be able to connect to the virtual machine through the web browser. But as my labs will become more complex and they required lot of machines and more machines to simulate some kind of infrastructure, not only the single PC. In the public cloud, it is a little bit expensive. So as the last iteration, I wanted to use some kind of lightweight detections lab, like a bunch of containers running on one machine, either virtual or physical. So the Docker and Docker Compose is very good for that. And I decided to simulate a small company infrastructure in Docker Lab. Next slide, please. So I decided to use the following components: Nginx as a web server, content management system or some kind of web application, WordPress with a MySQL database. There is also simulation on the workstation, like Linux server or desktop. And there is also possibility to connect another machines, like remote workers and so on, with WireGuard. These kind of machines could be either physical or another virtual machines, which can connect through WireGuard directly inside the Docker network. And thanks to the WireGuard UI, it is also very easily manageable through the web browser. And regarding the monitoring, for the IDS and IPS and so, I choose Suricata and logs from the Suricata, the alerts, traces, and so on, as well as all other logs from the other components, like access and error logs from the web server, are further processing with FluentBit and delivered to some OpenObserve, which is some kind of lightweight theme. So next slide, please. Okay. So the lab is very easy to start. It can be up and running in 5 minutes. It is very low on resources. It requires something like that. It is able to run either on very cheapest virtual private servers and 10 clients. And all of this is manageable through web browser, including the Kali Linux, with shell in the box, and we can use this Kali Linux to simulate the attacks, which can be further analyzed with OpenObserve CM. So next slide, please. There are a couple of examples of pre-configured dashboards in the lab. This is alerts, net flows. Next slide. Net flows from the Suricata, and last slide. Some kind of statistics from the access logs, and yeah, that's all because I'm running out of time. So next slide, please. If you are interested, all of this is included in GitHub repository, included some example scenarios for attacks and analysis. So thank you so much.